Aging is often imagined as a dramatic turning point, a sudden betrayal by the body, but biology tells a quieter and more honest story. The body does not wake up one morning and decide to grow old. It accumulates age the way stone accumulates weather, through countless small interactions between cells, nutrients, hormones, and time. Every meal, every night of sleep, every moment of stress or calm becomes a microscopic vote for either repair or erosion. When we look at someone who appears younger than their years, we are not witnessing luck or genetics alone, but the long-term outcome of repeated biochemical decisions that favored stability over chaos. At the cellular level, aging is less about damage itself and more about the body's capacity to respond to that damage. Cells are designed to renew, replace, and recycle their components with remarkable efficiency, but this system has limits. When the body is constantly forced to manage excess sugar, inflammatory fats, or artificial compounds, its resources are diverted away from regeneration and toward containment. Repair becomes rushed, incomplete, and eventually postponed. Over years, this delay becomes visible in the skin, the posture, the energy levels, and the clarity of thought. One of the most misunderstood ideas about aging is that it is driven primarily by time. Time matters, but only because it multiplies behavior. A single inflammatory meal does little harm, just as one night of poor sleep rarely leaves a lasting mark. But repeated exposure creates a biochemical environment where stress hormones remain elevated, blood vessels lose flexibility, and mitochondria become less efficient at producing energy. The body adapts to survive these conditions, but adaptation is not the same as thriving. Survival mode biology ages faster because it prioritizes short-term stability over long-term renewal. Inflammation plays a central role in this slow accumulation. In small doses, inflammation is protective and necessary, a signal that initiates healing. When it becomes constant, it quietly degrades tissues from within. Collagen fibers lose their organized structure, joints lose lubrication, and cells communicate with increasing distortion. The face begins to reflect what the immune system has been negotiating for years. Wrinkles, fatigue, and stiffness are not cosmetic failures, but biological records of chronic internal effort. Aging also accelerates when the body is repeatedly asked to interpret unfamiliar inputs. Modern foods often arrive in forms the human body did not evolve to process efficiently. When enzymes struggle to recognize these substances, metabolic pathways become strained. Detoxification systems work overtime, oxidative stress increases, and the balance between damage and repair shifts. Over decades, this imbalance becomes the defining feature of aging, not because the body is weak, but because it has been overburdened. Perhaps the most profound insight is that aging reflects consistency more than intensity. Extreme behaviors matter less than everyday habits repeated without pause. The body responds not to what we do occasionally, but to what we do habitually. Cells remember patterns. They adapt their structure, their signaling, and their resilience based on what they encounter most often. When nourishment is predictable, inflammation remains low, and energy production stays efficient, the biological clock slows not by stopping time, but by reducing the cost of living within it. What we often admire as youthful appearance is actually biological efficiency made visible. It is the absence of chronic struggle, the smooth flow of metabolic processes working in cooperation rather than conflict. Aging, in this sense, is not an enemy to defeat, but a feedback system revealing how gently or harshly we have treated the machinery of life. The body keeps score quietly, patiently, and without judgment, recording each small choice as another line in the story it tells through our skin, our movement, and our vitality. Blood sugar is not just a number on a lab report, it is a rhythm that shapes the tempo of aging inside the body. When glucose rises and falls gently, cells interpret it as a stable environment, one where energy is available without threat. When it spikes sharply and crashes repeatedly, the body enters a state of constant correction. Insulin is released not as a subtle signal but as an urgent command, and over time this urgency reshapes metabolism in ways that accelerate aging long before disease is diagnosed. Each rapid surge of blood sugar triggers a cascade of biochemical reactions designed for short-term survival. Glucose molecules bind to proteins in a process called glycation, stiffening tissues and altering their function. Collagen, the protein that gives skin its firmness and blood vessels their elasticity, is especially vulnerable. As glycation accumulates, collagen fibers lose flexibility and resilience. The result is not only visible in the mirror as sagging or fine lines, but felt internally as reduced vascular adaptability and slower tissue repair. The pancreas works tirelessly to manage these fluctuations, releasing insulin again and again to push excess glucose into cells. Over years, cells become less responsive to insulin's signal, not out of defiance but exhaustion. This insulin resistance forces the body to produce even more insulin to achieve the same effect, amplifying inflammation and oxidative stress. What begins as a metabolic adjustment quietly becomes a biological burden, accelerating the wear on blood vessels, nerves, and organs. Blood vessels are among the first structures to reflect this stress. High glucose levels damage the delicate lining of the arteries, impairing nitric oxide production, which is essential for vascular relaxation. Without this flexibility, vessels become stiff and narrow, reducing efficient blood flow to the skin, brain, and muscles. Poor circulation deprives tissues of oxygen and nutrients, slowing regeneration and making the aging process visible and tangible. The face loses its glow not because of age alone, but because delivery systems inside the body are no longer operating smoothly. The brain is not immune to this process. It relies heavily on stable glucose levels for clarity, memory, and emotional regulation. Frequent spikes and crashes create a state of neurological turbulence, increasing stress hormones and impairing synaptic function. Over time, this instability contributes to mental fatigue, mood fluctuations, and cognitive decline. The mind begins to age alongside the body, not because of years lived, but because of metabolic inconsistency. What makes blood sugar so powerful in shaping aging is its frequency. Few substances interact with the body as often, multiple times every day, year after year. Each meal becomes a metabolic message, either reinforcing balance or demanding correction. Diets dominated by refined carbohydrates train the body to expect volatility, while stable, fiber-rich foods encourage gradual energy release and metabolic calm. The difference between these patterns is not dramatic in a single week, but profound across decades. Youthful aging is closely tied to preserving insulin sensitivity and vascular flexibility. When glucose remains controlled, inflammation stays low, repair processes proceed efficiently, and tissues retain their youthful structure. The skin repairs micro-damage overnight, muscles recover faster, and the brain maintains sharper focus. These are not cosmetic benefits, but systemic outcomes of metabolic harmony. Avoiding constant blood sugar spikes is less about restriction and more about respect for the body's signaling systems. It is an acknowledgement that the human organism thrives on predictability and balance. When glucose behaves like a steady tide rather than a crashing wave, the body spends less energy on emergency responses and more on renewal, allowing age to advance without dragging the body into premature decline. Fats are often discussed as fuel or storage, but their deeper role is architectural. Every cell in the body is wrapped in a membrane built largely from fats, and the quality of those fats determines how well a cell can listen, respond, and adapt. When fats are natural and minimally altered, cell membranes remain flexible and intelligent, allowing signals to pass smoothly between the inside and outside of the cell. When fats are industrially processed, overheated, or chemically stabilized, they become structural imposters, integrating into membranes while subtly changing how those membranes behave. Industrial fats are not neutral passengers. They alter the fluidity of cell membranes, making them either too rigid or unpredictably permeable. This disrupts receptor function, meaning hormones, neurotransmitters, and immune signals arrive but are poorly interpreted. Insulin may knock but not be fully welcomed, inflammatory signals may linger longer than necessary, and repair signals may arrive later distorted. Over time, this miscommunication creates a background state of metabolic confusion that accelerates aging without dramatic symptoms. Inflammation becomes the common language spoken in this environment. The immune system recognizes that something is off but cannot easily remove the source because these fats have become part of the cellular structure. Instead of acute inflammation that resolves quickly, the body shifts into a low-grade, chronic inflammatory state. This subtle immune activation consumes energy, generates oxidative stress, and gradually erodes tissue integrity. Joints lose their smooth movement, muscles recover more slowly, and the skin loses its capacity to repair itself efficiently. The brain is particularly sensitive to fat quality because it is composed largely of lipids. Neural membranes rely on precise fat composition to maintain electrical signaling and synaptic plasticity. When industrial fats replace naturally occurring ones, nerve signaling becomes less efficient. Reaction times slow, mood regulation becomes less stable, and mental clarity requires more effort. Aging of the brain often begins not with memory loss, but with increased mental friction, a sense that thinking takes more energy than it once did. Blood vessels also reflect this internal shift. Healthy fats support the production of anti-inflammatory compounds and maintain endothelial function. Industrial fats, by contrast, impair nitric oxide signaling and promote vascular stiffness. This reduces blood flow efficiency and increases mechanical stress on vessel walls. Over decades, this contributes to hypertension, impaired circulation, and visible signs of aging such as dull skin tone and reduced physical endurance. One of the most deceptive aspects of industrial fats is their invisibility. They are designed to be stable, flavor-neutral, and long-lasting, making them ubiquitous in packaged foods. The body cannot easily distinguish them from natural fats at first, allowing them to accumulate quietly within tissues. Their effects are not immediate or dramatic, which makes them easy to ignore. Yet their influence compounds slowly, reshaping cellular behavior with each exposure. Aging in this context is not caused by fat itself, but by informational distortion. Cells rely on membrane composition to decide how to respond to their environment. When that information is corrupted, responses become inefficient or excessive. Repair processes slow, inflammatory signals persist, and metabolic pathways drift away from balance. The body adapts as best it can, but adaptation to a flawed signal is never optimal. Longevity favors fats that the body recognizes and has co-evolved with. These fats support membrane fluidity, reduce unnecessary inflammation, and preserve the clarity of cellular communication. When the structural integrity of cells is protected, tissues age more slowly and predictably. The body remains resilient not because time has been stopped, but because its internal architecture continues to support cooperation rather than conflict between its systems. Protein is often framed as a simple building material, something the body uses to construct muscle, enzymes, and tissue, but its true role is informational. Each protein we consume arrives carrying a pattern the body must interpret, disassemble, and reassemble into human form. When protein is whole and minimally altered, this process is efficient and quiet. When it is heavily processed, fragmented, or chemically modified, the body receives a distorted message, one that requires extra interpretation and often triggers unnecessary defensive responses. Processed proteins differ from natural ones not just in source, but in structure. High heat, chemical preservatives, and mechanical alteration change amino acid configurations and create compounds the immune system does not immediately recognize as safe or useful. The gut, which serves as both a digestive and immune organ, becomes the first line of negotiation. Instead of calmly absorbing nutrients, it activates surveillance pathways, increasing permeability and immune signaling. Over time, this low-grade activation contributes to systemic inflammation that accelerates aging at a cellular level. Muscle tissue is particularly affected by this confusion. The body relies on precise amino acid signals to stimulate muscle protein synthesis and repair micro-damage from daily movement. When those signals are incomplete or misleading, repair becomes less efficient. Muscles may still grow or maintain size, but their quality changes. Strength declines faster, recovery takes longer, and connective tissue becomes more prone to stiffness and injury. This is often mistaken for inevitable aging, when in reality it reflects years of suboptimal biological input. The immune system plays a central role in this process. Processed proteins can act as mild irritants, not enough to cause acute illness, but enough to keep immune cells partially activated. This constant vigilance consumes energy and increases oxidative stress. Resources that could be used for tissue renewal are diverted toward monitoring and containment. Over decades, this subtle shift leaves the body less capable of deep repair, making signs of aging appear earlier and progress faster. Hormonal signaling is also influenced by protein quality. Amino acids are precursors for hormones and neurotransmitters that regulate mood, metabolism, and sleep. When protein intake is dominated by altered sources, these pathways receive inconsistent input. Hormonal rhythms lose precision, contributing to fatigue, disrupted sleep, and metabolic inefficiency. The body becomes less synchronized internally, and this desynchronization manifests as accelerated aging across multiple systems. There is also a digestive cost that accumulates quietly. Processed proteins often digest either too quickly or incompletely, leading to rapid amino acid spikes or fermentation by gut bacteria. Both scenarios can disrupt metabolic balance. Rapid absorption strains insulin signaling, while incomplete digestion increases the production of inflammatory byproducts. The gut microbiome, which plays a critical role in immune regulation and nutrient absorption, shifts toward a less favorable composition, further amplifying inflammation and metabolic stress. Youthful aging depends on the body's ability to trust what it consumes. When food arrives in a form that matches evolutionary expectations, digestion is smooth, immune activation is minimal, and repair pathways function optimally. Whole proteins support not just muscle mass, but connective tissue integrity, skin resilience, and organ health. They allow the body to allocate energy toward renewal rather than defense. Avoiding heavily processed proteins is not an act of restriction, but an act of reducing biological confusion. It simplifies the body's interpretive workload and lowers the constant background noise of immune activation. Over time, this clarity preserves muscle quality, hormonal balance, and tissue resilience. The body ages more gracefully when its building materials arrive as coherent information rather than fragmented signals that must be managed rather than used. What we describe as staying young is often misunderstood as a battle against time, but the body experiences aging more as resistance than as years. Every biological system functions best when movement, signaling, and repair occur with minimal friction. Friction inside the body is created when cells are forced to constantly correct, defend, or compensate rather than simply maintain and renew. Youthful aging, in this sense, is not about stopping biological clocks, but about ensuring that the machinery of life runs smoothly enough that time leaves fewer marks as it passes through. Internal friction accumulates when metabolic systems are repeatedly pushed outside their optimal range. Blood sugar spikes, chronic inflammation, oxidative stress, and hormonal disruption all act as forms of biological drag. Each one demands energy to manage, diverting resources away from repair and regeneration. When this drag becomes a daily condition rather than an occasional event, the body adapts by prioritizing survival efficiency over long-term resilience. Muscles become less elastic, skin repairs more slowly, and cognitive sharpness fades, not because the body is failing, but because it is constantly busy managing imbalance. Repair and renewal are the default states of a healthy organism. Cells are designed to recycle damaged components, replace worn structures, and restore function during periods of rest. Sleep, fasting windows, and calm metabolic states activate these processes most effectively. When the body is overwhelmed by frequent insults, these renewal windows shrink. Autophagy becomes less efficient, mitochondrial turnover slows, and damaged proteins accumulate. The visible signs of aging emerge when renewal can no longer keep pace with ongoing wear. One of the most overlooked contributors to internal friction is predictability. The body thrives on patterns it can anticipate. Regular rhythms of eating, movement, and rest allow hormonal systems to coordinate efficiently. When these rhythms are disrupted by constant snacking, irregular sleep, or metabolic volatility, the body remains in a reactive state. Reaction is energetically expensive. Over time, this expense is paid in reduced tissue quality and diminished vitality. Stress, both psychological and physiological, further amplifies this friction. Stress hormones are invaluable in short bursts, sharpening focus and mobilizing energy. When elevated chronically, they interfere with collagen synthesis, impair immune regulation, and accelerate muscle breakdown. The face often reflects this internal state, appearing tense or fatigued, while the nervous system remains on alert even during rest. Aging accelerates. When calm becomes rare, the elegance of youthful aging lies in efficiency rather than intensity. It is not about extreme exercise, rigid diets, or aggressive interventions, but about removing the factors that force constant correction. When inflammatory foods are reduced, when blood sugar remains stable, and when fats and proteins align with biological expectations, the body requires less supervision from its own defense systems. Energy becomes available for deeper maintenance rather than surface-level survival. The systems of the body are not isolated, they age together. Blood vessels influence skin quality, gut health shapes immune tone, and muscle activity affects hormonal balance. Reducing friction in one system often eases strain in others. This interconnectedness explains why small, consistent changes can have disproportionate effects over time. A calmer metabolic environment improves sleep, better sleep enhances repair, and improved repair slows visible aging. In this framework, age becomes less about decline and more about adaptation quality. Two bodies can live the same number of years, yet one carries time lightly while the other bears it heavily. The difference lies in how much internal resistance each body has endured. When the body spends most of its life in a state of balance rather than correction, it retains flexibility, clarity, and strength longer. Time continues its forward motion, but it moves through a system designed for flow rather than friction, allowing aging to unfold as a gentle transition rather than a rapid collapse.